Now it started. So, hello everyone. My name is Maral and I'm attorney at law from Turkey and my dear colleague, dear Vijay from India. He is the founder and CEO of Alpha Singularity Re and D Lab. Thank you for joining today's World Space Week webinar titled Exploring Tomorrow from Mars to the Moon, AI Living in Space and the Legal Framework. World Space Week, celebrated each year from October 4th to 10th, is the largest annual event dedicated to space science and technology. It reminds us how space exploration continues to inspire innovation, unite nations, and shape the future of humanity. Today, we are both representing two essential perspectives. I'll be focusing on the legal side, while Vijay will cover the technology. This collaboration perfectly reflects the spirit of World Space Week, which celebrates how science, technology, and love come together to shape humanity's journey beyond Earth. Now, I would like to hand it over to my partner, Vijay. Vijay, the stage is yours. Could you please continue with your part of presentation?
Thank you so much for the introduction. I'll just share my screen. Yeah, is it visible?
Yes, your screen is visible. There's no problem. Thank you very much.
Yes. Okay, so today's topic of webinar is basically new space age, where living in space is something that humanity has been thinking of since decades. So with technologies like AI and digital twins, this is actually possible. Basically, there are a number of technologies that can be implemented for living in space and exploring the extraterrestrial life. But AI and digital twins are specifically the target of this webinar, considering the time constraint. Let's go through the agenda. So first we begin with interplanetary tech. We understand what is the tech that is currently available and accessible to us. We'll look at space networks. We'll look at digital twins in detail. We'll look at AI and autonomy, and the checklist for mission planners who intend to explore the extraterrestrial planets and live in space. And then of course, the takeaway. Let's look at interplanetary tech first. So basically, what we are looking at is artificial intelligence and digital twins technology, where this tech actually helps us and makes living and working beyond Earth possible. So AI enables us to explore the different planetary life, and with this technology, we can also enable augmented reality, virtual reality, and mixed reality. So basically, mixed reality is nothing but a combination of augmented and virtual reality. So here, what happens is, let's say we have a rover that is exploring Mars, and it comes across an object, let's say stone, Mars stone. It comes across a stone, and it wants to send the image of that particular stone back to Earth, and people on Earth want to see how the Martian object looks. At that point in time, we can do this through augmented reality. So basically, rover can, through augmented reality, send the image of that Mars stone back to Earth, and people who are having access to the headsets here can actually visualize that Mars stone here on Earth. So this is how the interconnection happens between two different worlds. So now, if we consider living in space, living on any planet, for instance, it may be Mars or Moon, we need three important things. One is basically reliable communication. Since the distance is a bottleneck that we face, the planets are quite far away from planet Earth. So reliable communication needs to be established. That's point number one. Second is smart automation. This comes into picture because we do not have direct control over the devices that are exploring or that are being placed on other planets. And since we cannot control them in real time, we need automation systems so that those devices can navigate themselves. Okay. Third thing is, so we need digital models to mirror people and systems that are on the other planets so that we understand what they are going through and what situation they are facing. So we need digital models as well. So these form the backbone of life beyond Earth. Now, if you want to move to other planet, it is important also to establish a connection where we are able to transmit or send big data of whatever we have developed on planet Earth to other planet. So basic modules that are being explored are radio links. For instance, they are good enough. But to send HD video and big medical files, we need laser links. Now the difference between radio links and laser links is that radio links are typically prone to interference. So a lot of noise gets attached to these signals, and because of which transmission of accurate data is not possible. And that is where laser links come into picture. Now, NASA's DSOC basically stands for Deep Space Optical Communication. They have already tested this technology, and if we see the speed, they have hit about hundreds of Mbps at short distances and tens of Mbps at Mars-like distances. Okay, this technology, NASA's DSOC, typically uses infrared laser signals, and it has been observed and studied that the speed that is achieved through this technology is 10 times more than the radio communication. So the image that you see here is basically this DSOC system in working. Basically, you have DSOC satellite and then you have DSOC radio center, which helps in transmission of data using the laser links. Now let's look at space networks. Now, if you observe the space is quite slow. Signals to Mars can take minutes to tens of minutes because of the distance parameter. That means we can't always control robots or treat people in real time from Earth. To cope up with this delay, NASA has introduced, or NASA has, started employing delay tolerant networking technology, where it is an interplanetary store and forward internet system, which lets us queue and route data reliably across multiple hops or nodes. It is much like not sending internet data directly, but rather queuing the data or buffering the data from hop to hop and then transmitting to the destination, so that there is no time lag between the data transmission and data reception. So that is the objective. Now let's look at disruption tolerant networking. Space communications are subject to frequent delays and unavailability of end-to-end links. DTN uses store and forward approach to overcome latency and disruption challenges. In the event of disruption between nodes, each node can store data until the next node becomes available. This is much like how emails are saved in outboxes until a network connection is established. So this typical DTN network mimics the email system of whatever when the connection is not available in email system, our mails basically go into the outboxes. So when connection is restored, then the emails are actually sent. This is the similar picture how delay tolerant networking works. So if we see in the image, there are multiple satellites in operation. So all of them have data in the buffered zone, and once the connection is fully established, this buffered data is finally transmitted to the spacecraft or any kind of object or and maneuver on the another planet like Mars. Now let's look at digital twins. So what is a digital twin? Digital twin is a living virtual copy of a real thing. It may be a rocket, habitat, or even a person that syncs with sensors and gets updated over time. Let's look at the image here. Now the physical asset here is the actual real-time mechanical object here. For instance, JCB here. It is fitted with number of sensors so that the data from that physical device can be collected by the computer that is developing the digital twin. It collects the sensor data and creates a digital twin. And once the digital twin is established, it can exchange real-time information between the actual object and digital twin. And the insights from digital twin can be back propagated and communicated to the actual physical asset. So NASA has built an Orion spacecraft digital twin to support Artemis project and found its speed troubleshooting by orders of magnitude. So once this digital twin is established, we can actually simulate what if scenarios which the physical object can come across. Now let's say we have a rover on Mars, Perseverance rover. Let's say it is moving in the habitat of the Mars, and we have a digital twin back on Earth. Once we have the digital twin, we can actually understand, based on the sensor data that is being sent back from the Mars object, what all environment is this Mars rover basically coming across to. And based on that, we can actually summarize what if scenarios or design scenarios, or we can also predict if what failures can occur to that particular outer terrestrial object. Now let's look at digital twin use cases. Digital twin can be used for simulation and rehearsal for landings and dust storms. This can be simulated using a digital twin because we have sensor data from the actual physical object. Predictive maintenance for life support and power systems. We can predict beforehand whether a failure to a particular space component can occur or not, to let's say a component within a spacecraft, whether that can fail in the coming time can be predicted using this technology. Training and remote troubleshooting for astronauts and ground teams. So NASA's Orient Twin already has modeled thousands of components and proved useful for mid-mission decisions. Okay. But basically, let's understand how are these digital twins created. Now here comes the picture of AI. AI is a tool to enable this digital twins. Let's consider the creation of digital twin, for example, here. Now let's say we have an object of a satellite. Uh, on the left hand side, you can see there is a physical object here. We now this physical satellite has number of sensors fitted onto it, which collects sensor data and gives to the computing system. Now sensor data can be from different systems like power system, communication system, altitude system. Now the computing system will collect all this sensor data. It will develop monitoring parameters like acceleration, voltage, electricity, temperature, frequency, force, different parameters. Once parameters are collected through the sensor data, it then develops the machine learning model, where different models are developed. One model may be for altitude matching adjustment, another may be for temperature control, another may be for mechanical model. All such models are developed. Once these models are developed, then different algorithms and rules are designed and developed. It may be with relation to expert knowledge, so the rules can be developed. Different diagnosis algorithms can be developed in case of predictive fault tolerance and fault maintenance. Once all of these rules and algorithms are developed, along with the models, they are fused together, and then eventually a virtual satellite is created from the physical model. This is how AI helps in developing the digital twins. So imagine a health twin for every colonist that is out there. His heart data, stress markers, sleep, or radiation dose all can be fed into this model that can help doctors to predict the risk and suggest countermeasures if such eventuality occurs. Researchers and NASA are actively prototyping human medical avatars and digital twin platforms for astronaut health monitoring. Now, health is something which needs to be tracked when a person is not in the gravitational zone of the Earth. Since it is microgravity area, its health parameters can be tracked using this digital twin model. Now, all that is said and done, it's a powerful technology, but it raises few important questions like privacy and ownership questions. For instance, who owns your digital twin? The astronaut, the mission, or the company that runs the software? Now, these are some of the legal aspects that my next speaker will dive into. If you look at digital development, it has been there since a very long time. The conceptual introduction was done in 2002. In 2010, it was first applied to spacecraft design. Then real-time monitoring of spacecraft's health status was done in 2015. In 2020, supporting remote operation and performance evaluation was done. And last year, full life cycle management of a spacecraft was accomplished through this digital twin. And now in 2025, we are moving towards integration of deep learning, deep machine learning into this digital twin technology. So AI has been integrated at a full-fledged level in this digital twin technology. Let's look at a small simple video. It basically tells us how this digital twin works in case of satellites. This is how the digital twin basically works. So it collects sensor data and then simulates different situations that can occur or that the actual physical object encounters. Now let's look at AI and autonomy. So due to delay and risk that are involved in the outer terrestrial space, vehicles and habitats must think locally. Now, rovers like NASA's Perseverance drive themselves using onboard autonomy. Now, AutoNav is a automated navigation system that the Mars Perseverance rover is basically having. So it has number of components which run autonomously. For instance, it may be laser micro imager, it may be weather station, it may be ultraviolet spectrometer, X-ray spectrometer. Using these different components, the Mars rover is able to navigate autonomously, and rather than relying on human input or human interference. What about the hardware and robustness? The space computers must be radiation tolerant. This is an important factor since space is open to radiation out there, due to different radiating planets and stars like sun. New space grade processors and neuromorphic chips must be designed in a way that can withstand this radiation and can also run AI in harsh environments. That matters because normal data centers GPUs don't survive in this radiation prone environment. What about privacy, security, and policy? Space systems are tempting targets for cyber attackers. We have seen real satellite cyber incidents and reports that flag commercial satellite cyber security as a growing threat. So privacy and security is a factor that must be thought of by the mission planners at the first go. So the takeaway here is to encrypt data in transit and at rest. We must use hardware that are trustable, and we must limit data which leaves the actual habitat. So basically, to sum it up, it is much like encrypting data, whether it is in transit or at rest, so that even if it is being attacked by cyber attackers, they cannot actually read the data. There are a few AI risks that are involved here. Three quick AI risks are basically models trained on Earth fail in alien environments. So basically, what happens is no matter what we design as a digital twin here, the actual environment cannot be simulated because there are a lot of unknown variables that the actual physical object can come across in the extraterrestrial space, and that is where the models that are trained on specific data cannot understand these unknown variables. There can be adversarial or supply chain attacks on onboard AI. It is much like the cyber attacks. And then, of course, loss of human control if systems become too autonomous without clear override modes. So basically, if autonomous systems are navigating by themselves, then they do not need human interference. So so in that case, the devices can go out of hand. They can go out of control, and they can perform their own operations uh, without the need of the humans. These are some AI risks. There is a basic checklist which the mission planners can take into consideration, while living in space or while planning to live in space. So before putting people and data in space, it's important to consider and plan. Firstly, plan communication. It may be radio frequency, laser, or delay tolerant networking. Build twins for critical system and for crew health. So if there is something critical propulsion system, we need digital twin for that so that we can predict in case of failure if it occurs, when it can occur. Another for crew health, so we need digital twin for crew health monitoring. We need to harden our AI and hardware and test under radiation fault injection. So that our physical components can withstand the outer radiation, we need to develop robust hardware for these devices. We must lock down cybersecurity and legal data governance plans early so that there is no data breach later on once the mission is launched. So the eventual takeaway from this technology is that policy plus tech equals safe colonization. Build privacy by design rules for personal twins. We must have privacy rules for these digital twins. We must have explainable AI for mission critical decisions and make international agreements between countries and nations and agencies, space agencies, to protect off-planet personal data. Right? Space gives us fresh air and fresh questions. Tech can solve many problems, but we must keep people and their rights at the center while diving into this far-reaching technology. These are some of the selected references, and thank you.
Thank you very much for this amazing presentation. And
Thank
now
you.
I'm going to talk about something that's been in our dreams for centuries, space colonization. The idea of living in space is no longer just a fantasy. It's turning into a real, actual plan. First stop, the moon. NASA's Artemis program is on a mission to put humans back on the moon by the 2030. One of the most exciting aspects of this effort is the exploration of 3D printing habitats using lunar soil, a technology that could significantly reduce the cost and complexity of building structures on the moon. Researches in this area is already underway with companies like ICON and universities such as the University of Colorado. And did you know that China and Russia are teaming up to create a new international lunar research station? In addition to NASA's effort, China and Russia have initiated the International Lunar Research Station, a joint project aimed at building a permanent lunar base for scientific research. Also, some bold thinkers like MIT are invoicing the Moon Village concept. So now let's talk about Mars. It's a bit further down the road. NASA's Perseverance rover is busy gathering data and exploring the Martian surface, getting everything ready for the big day. SpaceX is developing its super cool spacecraft Starship, aiming to get astronauts to Mars. But let's be real, colonizing Mars is a whole different ball game. It's far, it's cold, and getting there is no easy feat. Plus, there are some big questions to answer, like how to survive in an environment that hates us. I mean, no air, freezing cold, and dust storms that could ruin your day. Experts are still skeptical about building a self-sustaining colony without a lot of Earth's backup. And don't get me started on space resources. It's a bit like everyone fighting over the last piece of cake. So for those of you curious about the latest Mars missions, including the incredible work of NASA's Perseverance rover and advancements in reusable spacecraft, you can read more about in Ilyas Erol and Yunus Erol twin brothers article on Mars on Earth project. I will be share the links on our WhatsApp group. So what does all mean? Space colonization is no longer just something we talk about in movies. We are actually planning for it, and we have got a big ideas, big teams, and big tech to get us there. But there is still a lot of work to do before we can pack up our bags to Mars. Now that we had our fun with space dreams and lunar villages, it's time to bring things back down on Earth, literally. And unfortunately for the dreamers, this next part is all about the legal side of space colonization. So let's start on our legal dive into legal frameworks, current gaps. So love usually chases after technology, but this time I decided to let love take the first step. After all, we are exploring tomorrow, whether on Mars or in the moon. Someone has to make sure even AI and digital twins don't forget the legal framework. These are the possible scenarios and forecasts for our near future. Instead of waiting for technology to surprise us, I figured love should surprise technology for a chance. In the context of colonization, I refer to the exploration of the moon or other celestial bodies as outlined in the Outer Space Treaty, 1967. Specifically, the treaty emphasizes that the exploration and use of outer space should be directed for the benefit of all countries, regardless of their level of economic or scientific development. It is clear from the treaty's provision, particularly Article 2, that outer space, including the moon and other celestial bodies, cannot be subjected to national appropriation, whether by claims or sovereignty, use, occupation, or any other means. Therefore, term of colonization in this context must be understood not in the traditional sense of territorial conquest or dominance, but rather as a concept of scientific exploration and sustainable habitation. This approach aligns with the initiation of the entered into force 1984 agreement governing the activities of states on the moon and other celestial bodies in moon agreements. In short, Article 9. Legally, the Outer Space Treaty from 19 67 remains the foundational document preventing national sovereignty claims and assigning responsibilities to states for their space activities. However, the question of how settlements on Mars or Moon will be governed is still an open issue. Is this treaty doesn't fully address the increasing role of private companies, resources extraction rights, or how space colonies should be governed, especially in terms of data and digital technology. Future legal frameworks may need to address how to establish peaceful and cooperative settlements possible through international treaties or agreements. Next, let's focus on digital twins in space. That's right, we are sending virtual colonies, rockets, satellites, and maybe even space station into orbit because why should astronauts have all the fun? One of the most transformative technology for colonization is the use of digital twins, virtual model that simulate everything from environmental conditions to life support system. These tools help manage the construction and daily operation of colonies remotely, for example. So personal digital twins that mirror individuals' colonist health, psychological state, and social interactions will be used to optimize well-being. But this raises serious privacy and ethical questions. If you want to dive deeper into the concept of digital twins and how they are shaping the future, I've got something for you. You can explore this future in my published book. I can send the links to our WhatsApp group. So, personal data and privacy concerns. Currently, terrestrial data protection laws like GDPR offer strong privacy safeguards on Earth. However, their scope of planet is unclear. International space law mainly covers environmental and remote sensing data, leaving personal data protection in space a significant legal gray zone. We urgently need new frameworks to address ownership, consent, and ethical use of personal data in extraterrestrial environments. Singularity scenario. Looking future ahead, digital twins might evolve into super intelligent AI with autonomy beyond human control. This could lead to loss of personal agency, ownership conflicts over data, privacy risks, and social power shifts. Possible end of human-centric governance. We must consider these possibilities now before they become realities. Cybersecurity challenges. We already see terrestrial laws imposing heavy penalties for data breach, yet in space enforcing this protection is far more complex. The cross-jurisdictional nature of space activities demands international cooperation to establish cybersecurity rules that protect personal data and prevent misuse beyond Earth. So if we conclude recommendation. In conclusion, while space colonization holds great promise, it also exposes critical gaps in law, ethics, and cybersecurity. To ensure a safe, ethical future, we must develop dedicated space data protection law, adopt the extend Earth's privacy law to space context, regulate AI and digital twins with transparency and accountability, foster international cybersecurity cooperation, incorporate personal data protection explicitly into future space treaties. So, balancing innovation with rights protection will be essential as we embark on this extraordinary journey. Collaboration and foresight will help us create a space-faring future that respects human dignity and privacy. As we explore the infinite wonders of space, let us remember that the true progress begins here on Earth, with peace, unity, and cooperation among all nations. Instead of turning our energy toward conflict and division, humanity must come together to build, create, and dream. Because who knows, one day when finally meet life from beyond our planet, we may realize that our greatest strength has always been in our ability to live in harmony as a human family. Thank you for your attention. I'm happy to take any questions or hear your thoughts. Please write your questions to our WhatsApp group and let's discuss. So this was our World Space Week webinar. Thank you for joining us today.
Thank you all.
Mm-hmm. Bye bye.
Bye bye.